Today, there are only 3 living species of elephants: the Asian elephant, the African bush elephant, and the African forest elephant. But long ago, this mammalian order was quite diverse. Its history began 55 million years ago with Phosphatherium, a now extinct elephant species. Since then, elephants have shown an assorted genetic makeup to become the world's most iconic megafaunal family with as many as 14 reported genomes. These elephants differed vastly based on their shape, size, and habitat, which only points to interbreeding. Let us take the example of savanna elephants and woolly mammoths. While they do share common ancestors, they eventually split into separate species, which is quite evident from the way their tusks looked. As many as 180 elephant species are today extinct. Most of these names won't exactly roll off your tongue, but these elephants have been some of the most important ancestors that researchers have identified. Let us get to know a few of the prehistoric elephants that have been a part of the functioning of some amazing but former ecosystems of the animal kingdom. Stegotetrabelodon. Stegotetrabelodon was native to, very surprisingly, the Arabian Peninsula. While it today remains a desert, back in the time, the Arabian Peninsula was theorized to be a subtropical forest with abundant vegetation. A few of these elephants wandered to Africa, where one Stegotetrabelodon grew as tall as 4 meters in height and weighed between 11 to 12 tons. In the year 2012, researchers came across preserved footprints of a Stegotetrabelodon's herd in the Middle East. These more than a dozen elephant footprints, varying across age and sex, have been termed as one of the most important ancestral elephant discoveries of our time. This discovery also supports the theory that the Arabian desert we know today was once home to megafaunal mammals. Woolly mammoth. The tundra and most parts of the taiga were once home to these mammoth steppe. Woolly mammoths were quintessential representatives of the Ice Age, so it is hardly a surprise that their coat was made up of foot-long hair with an undercoat of shorter hair. These grazers roamed around ecosystems with abundant grasses and shrubs. Even 10,000 years after their disappearance, these remain one of the most popular prehistoric elephants. Today, the woolly mammoth DNA is with the scientists who plan on reviving the species in an attempt to convert the tundra back into a grasslands ecosystem. While this is only theoretically possible, who knows, we may soon see a woolly mammoth. Phosphatherium. Can you imagine an elephant the size of a dog? But some 60 million years ago, this small, pig-shaped elephant walked the plains of Africa. This animal seemed to look like a combination of a horse and a hippopotamus. Quite confusing for the paleontologists indeed. But fossil study confirmed that Phosphatherium had a proboscis lineage based on the skeletal structure of its skull and its teeth. Phosphatherium is believed to have enjoyed an amphibious lifestyle while munching on the tasty vegetation in northern Africa. American mastodon. This larger-than-life mastodon roamed the plains of North America until 13,000 years ago. Mastodons went extinct as a part of mass extinction, which is believed to have resulted from human predation and climate change. These giants often get confused with their cousins, the mammoths, but mastodons were distinctively shorter and stockier. However, their most distinctive feature was the cheek teeth. Their molars were cusp-shaped, which gave them the name mastos, meaning breast, and odon, meaning tooth, both Greek words. Complete or near-complete American mastodon skeletons have been recovered and are now well preserved. Anankus. They may not be the largest, but the Anankus's elongated tusks did stand out. Sometimes, as long as its body, its tusks grow up to 4 meters. These especially long tusks helped Anankus feed on vegetation that was way beyond the capabilities of other herbivores. They used their tusks to first uproot the plants, and later, using its trunk, these elephants would pick the plants and munch on them. A well-preserved Anankus tusk, believed to be 3.4 to 2.6 million years of age, was excavated from the sediments of Tatrat village in northern Pakistan. Surprisingly, this elephant tusk was the longest ever discovered in South Asia and was measured at a whopping 8.1 feet. Anancasses were believed to have originated in Asia and later entered Europe. Gomphotherium. Gomphotherium is unlike any elephant that we have ever seen before. Their scoop-shaped lower tusks give an impression that their mouth stays open. But in fact, this shovel-like tusk gave these elephants a great evolutionary advantage. It had 4 tusks, 2 on the upper jaw and 2 along the lower jaw. The lower 2 tusks were parallel to one another, acting just like a big scooper. This helped them scoop vegetation off the mud, flooded swamps, and riverbeds. Often called the welded beasts, these elephants had a rather longer geographical range. Researchers found that Gomphotherium roamed across North America, Eurasia, Africa, and even parts of Asia. Tetralophodon and Primalephas are 2 more elephant species with somewhat similar shovel-like lower jaws. These 2 were also known to have roamed the woodlands all across the world. Cypress dwarf elephant or Paleoloxodon cypriots. The Cypress dwarf elephant is a classic example of phyletic dwarfism, more so insular dwarfism, where large-bodied animals evolve into smaller-sized individuals due to many island-like conditions, including limited food resources and fewer predators. Remains of fully developed Paleoloxodon cypriots suggest that these elephants did not weigh more than 250 kilograms, a massive weight reduction from their ancestors. Researchers discovered close to 44 molars on the island of Cyprus that confirm that these elephants descended from the straight-tusked elephant species. Paleomastodon. Their long and flat skulls and 2 pairs of tusks definitely distinguish the Paleomastodon from other mastodons. Paleomastodon with their upper pair of tusks used to scrape bark off the trees, while the lower pair of tusks helped them scoop food off the ground. Together, the 2 pairs of tusks also served as a defense mechanism for the Paleomastodon. Some 36 to 35 million years ago, these elephants stomped across the swamps and marshes of northern Africa. Their resemblance to today's elephant seems very vague, rather they look more like a Moratherium, a short and stubby semi-aquatic mammal. Yet, they are believed to be the ancestors of both the elephants and mastodons. Moratherium. And now we move on to an elephant that did not look a bit like one. Moratherium looked like pigs, but had enough elephant-like features to find a place in the pachyderm camp. Smaller bodies with proportionately smaller tusks and trunks led these mammals to enjoy a hippopotamus-like lifestyle. Thanks to decades worth of Hollywood movies and games, most of us are convinced that elephants of the past looked a certain beastly way. But to know that they actually existed and adapted in ways we can hardly imagine only makes one wonder at the monumental amount of biological and organic changes that happened over millions of years. Also, the fact that elephant descendants come to differ from their ancestors only supports the long-inspired hypotheses about how environmental events and interactions collectively shaped animal evolution.